We know the things around us exist in forms of sets. Set is a collection of well-defined things. Well, have you ever thought whether you can count all the elements of a set? Consider this example. Set of concentric circles in a plane. You are provided with a center C. And somebody asks you to draw as many circles as possible. I drew all of these circles. Does that mean I cannot draw any more circles? I can draw infinite circles of any radii with the same center in a plane. Thus, we can say set of concentric circles in a plane is unbounded. Such type of set which is unbounded or unlimited is called an infinite set. Now, if we are given some specific radius of the circle, then you are asked to draw circle. How many circles can you draw? What will be your answer? The fact is that one and only one circle can be drawn with the given center and the given radius. So, the set of circles with a given center and radius is a countable thing. Such type of set which is countable is called a finite set. Finite set is defined as a set which contains a definite number of elements. The number of distinct elements in this set is denoted by its cardinal number. The cardinal number of a set A is n of A. For example, if P is equal to set B, A and D, how many elements are there in the set? Here we have 4 elements in the set. So, its cardinal number will be equal to n of P, which is equal to 4. Let's see how we can represent a finite and infinite set using roster 4. In a finite set, the elements are represented within the curly braces and are separated by commas. For example, set of all odd numbers within 10. What you will get? A is equal to 1, 3, 5, 7, 9. While framing an infinite set using roster form, since the number of elements are not finite, we write a few elements and then preceded by 3 dots. For example, set of all even numbers. We get B is equal to 2, 4, 6, 8, 10, etc. Here, you can see that the 3 dots or the dots here in the example shows that it is a never-ending series. Let's move our discussion to the next type of set, that is empty sets. Set with no elements present in it is called an empty set or void set, or it can also be called as null set. Sometimes people compare an empty set to a bucket or empty glasses. One empty glass makes an empty set. Usually the symbols curly brackets or phi are used to depict an empty set. Also, the cardinality of an empty set is always 0. Mathematically, we can write it as n of phi is equal to 0. Now, put an empty glass into a bucket. You have got a set, that is your bucket, containing an empty set. That is your empty glass. Can you tell me how to represent a set containing an empty set? Let's use the letter capital S to denote the set. So we have set S is equal to set phi within the curly brackets. Here the cardinality of the set n of S is equal to 1. Therefore, it is not an empty set. Thus, we have observed the difference between an empty set and the set containing the empty set. So far, we have discussed the 2 types of sets, finite infinite set and the empty set. Next we will discuss another important kind of a set. Equal sets. Now what are equal sets? Sets which contain identical elements are called as equal sets. The order of the elements can be different, but the cardinality of equal sets is always the same. One of the best example where the concept of equal set used is in a palindrome. What is a palindrome? A word, a number, or a sequence of words that reads the same backward and forward is called as a palindrome. Let's see one example. Check whether the word level is a palindrome. Set F represents the set of letters of the word in forward direction. So we get F is equal to LEV, right? Set B represents the set of letters of the word in backward direction. So what is B? B is equal to LEV. We have omitted the repeating letters L and E in the both sets. Here, set F and set B have some elements listed in it. Also, N of F is equal to N of B is equal to 3. Alright? Therefore, set F is equal to set B. We can write F is equal to B. Thus, we can say the word level is a palindrome. Next, we will see what are subsets. Consider the sets V is equal to set of all vowels in English alphabet. L is equal to set of all letters in the English alphabet. We note that every element of V is also an element of set L. Or we say that V is a subset of L and they are represented as V subset L. So, we can define a subset as a set which contains the entire elements of some other set. Mathematically, A is a subset of B. If A is an element of A, implies that A is also an element of B. We can find a variety of examples of subsets in our daily life. For example, if all the school clubs forms a set, then arts club, music club forms a subset. Let's discuss some important properties of the subset. We know the first very important property is every set is a subset of itself. Second, empty set is a subset of every set. Third one, if A and B are two sets such that A subset of B and B subset of A if and only if A is equal to B. Similarly, the last one, if A and B are two sets such that A subset of B and A not equal to B, then we can say A is called the proper subset of B and B is called as the superset of A. Here is a table showing the different types of intervals which appear as subsets of real numbers. A and B within the round bracket means open interval excluding A and B. Second one, A and B within the square bracket. What does it mean? It means a closed interval including A and B. Third one, closed interval A and open interval B. It is an open interval including A but excluding B. And the last one, we have open interval A, closed interval B. What does it mean? It means open interval including B but excluding A. And its corresponding set builder notation is, first one, open interval A comma B, which is represented as X such that A less than X less than B. Second one, closed interval A comma B. Its corresponding notation is X such that A less than or equal to X less than or equal to B. Third one, closed open interval. Its representation is X such that A less than or equal to X less than B. And the last one is open close interval. And its corresponding representation is X such that A less than X less than or equal to B. Let's see the next type of set, that is power set. In set theory, power set of a set A is defined as the set of all subset of set A, which includes the set itself and the empty set. It is denoted by P of A. In power set, each element is a set. Now what about its cardinality? If set A has m elements, then n of A is equal to m. Then the cardinality of the power set is given by n of P of A is equal to 2 raised to 2m. This is a very important equation. Now my question is how to write power sets. Let's go through one example. S is a set of all letters in the word radar. So S is equal to set R A D. So in order to find the power set, we need to write first all possible subset of set S. So we will get a null set, set R, set A, set D, set R comma A, set R comma D, set A comma D, set R comma A comma D, the set itself, right? Now the power set is the set of all subsets of set S. Therefore, P of S is equal to curly brackets open, a null set, set R, set A, set D, set R comma A, combinations of two letters, set R comma D, then set A comma D, and the last set R comma A comma D. This should be everything within the curly brackets. Alright? Universal set. Universal set means it includes elements of all sets under consideration. In other words, we can say it is the master or head of all other sets. Other sets are derived from the universal set. Usually, the letter capital U is used to represent a universal set. All the stars in a Milky Way galaxy is a very good example of a universal set. Now that we have learned about the different types of sets, let's look at how operations are carried out on a pair of sets and we will examine their properties. Let's have a quick recap of what we have learned.
Manorama Horizon. Learning made simple.